What we're going to do today, guys, is the first day of section 7.3, which is going to be conducting basic operations on functions. So what I want you to do is take a look at the warm-up on the top of the guided note sheet, pause the video, go through and simplify this using all the exponent properties that we've been working on for the last few weeks. So give that a shot. So if we take a look at our warm-up, our final answer should be x to the 2/21st. So if we take a look at this, we're dividing two things of the same base, so we should subtract those exponents. So we're subtracting 3/7 and 1/3. To do that, we do not have a common denominator right now. We need to create that. Our common denominator would be 21. So I would need to multiply this by 3/3. I know that's kind of hard to read. And we'd also need to multiply this one by 7/7. That way we have 21 as both of our denominators. We can just subtract numerators. Those are just fraction rules, which we've been going over. So, quick note for today. What is called a power function is something denoted a constant times x raised to a power, where a is a real number and b is a rational number. So that may be something like 2x to the third, or that may be 4x to the 1/2. Alright, rational just means it can be written as a fraction. We're not like adding anything, we're not subtracting anything, it's in this format. And we're going to work a lot with those kinds of functions today. So that's called a power function. Whoops, I already just went over that. So, our operations, these are things that we have done before and we should feel confident doing. We're adding or subtracting, multiplying and dividing. When we add or subtract, we need to combine the like terms of our two functions. Okay, as it's showing here, it's just adding straight across. If we're subtracting, remember we need to distribute that negative sign to both, change the sign, then we're combining the like terms. For multiplication and division, we're really just using the exponent properties we've been doing. So if we're multiplying 2x here, we would distribute 2x times x. We're multiplying things at the same base, add their exponents, and then we'd also multiply their constants. And we would do the same thing with 2x times 1. When we're dividing, okay, what you'll see is we're going to typically have power functions that we can reduce. These two you can't reduce, so we would just leave it as 2x over x plus 1, and you'll see the kinds of examples that we can simplify. So, first example, f of x equals 2x to the 1/2, and g of x equals negative 6x to the 1/2. So we want to find the sum and then the difference. The sum, all we're going to take is f of x, and we're going to add g of x. F of x was 2x to the 1/2, and we're going to add negative 6x to the 1/2. Okay, so when we look at this, this is really just 2x to the 1/2 minus 6x to the 1/2. Now, this is not any different than if it were 2x minus 6x. We're combining the like terms. So we would do 2 minus 6, and it would give us negative 4x. If I have 2 apples, and I'm supposed to give 6 away, I'd be in debt of 4 apples. It's the same concept here. 2x to the 1/2 minus 6x to the 1/2 would be negative 4x to the 1/2. Okay, and we can leave it like that. But just remember, anytime something's written to the 1/2, that's essentially saying negative 4 times the square root of x. Okay, because x to the 1/2 can be written as the square root of x. Now, same idea with the difference. We're just going to subtract. So we're going to say f of x minus g of x. Now that'll be 2x to the 1/2 minus negative 6x to the 1/2. The two negatives become a positive. We would have 2x to the 1/2 plus 6x to the 1/2. And again, just like we did before, we would just add the coefficients. We have two things that are the same here, so we're combining the like terms. The 8x to the 1/2, you could also write that as 8 times the square root of x, because x to the 1/2 is the same exact thing as the square root of x. Nothing really different here, guys. So, with that in mind, what I want you guys to do, actually, you know what, we'll just go through this last one too. Look at this, the sum and difference of these two things again. So the sum, I'm going to combine the like terms. I would say 7x squared plus x plus 5. Looking at that, there is no like terms. So, with that in mind, we would just write 7x squared plus x plus 5 because there's nothing else I can combine. Nothing at all. And really the same thing when I look at the difference. I'm going to say 7x squared minus x plus 5. When we have something like this, remember we have to change the sign of both things inside here. So what we would have is 7x squared. We would then have minus x minus 5. Looking at those, Again, there's nothing that we can combine there because x squared and x are different terms and we can't combine them. So that would be our final answer here. Again, this is stuff that we did last chapter too. So really not much difference. Where things are going to change a little bit are going to be when we start including power functions, which we have right here. So I want to find the product and the quotient. Remember, product is when we multiply two things together. Quotient is when we divide them. So when we find the product would be, say, 3x times x to the 1/4. Okay, looking at these. This is just like what we did on the last quiz. Okay, we're multiplying things of the same base. You need to add those two exponents. 3 times 1, our coefficient would be 3. I have x to the first plus 1/4. I need to create a common denominator there. My common denominator would be 4 over 4. So it's a 3x to the 4 over 4 plus 1 over 4. And I would go through and add those two. I have two things of the same. I'm sorry, my denominators have the same. I'm sorry, my fractions have the same denominator. I can add those two things then. So it's a 3x to the 5/4. Alright, and that's how we multiplied. All we did is we took our two functions, multiplied our constants like we always have, and now we're multiplying x and x to the 1/4. To do that, we add their exponents, multiplying two things of the same base. And really, the quotients are going to be very similar. We're going to divide 3x and x to the 1/4. And just like to do now, what we need to do is we're dividing two things of the same base, we need to subtract their exponents. So we're going to have 3x, because 3 divided by 1 would just be 3, be 1 minus 1/4. Just like we did in part A, we need a common denominator. It would be 3x to the 4 over 4 minus 1 over 4. And I can simplify that. 3x to the 3/4. Okay? Really all that is just combining a bunch of the different skills that we've been working on. Nothing totally brand new. And what we'll do, we'll go through one last one, and then you guys will practice on your own. Product, we need to do 9x to the 4/3 times 3x to the 5/3. So looking at this, first things first, multiply the constants. 9 times 3 would be 27. We're multiplying two things of the same base, and x to the 4/3 and x to the 5/3. So what that means is I'm going to have to add my exponents. 27x to the 4/3 plus 5/3. 4/3 plus 5/3, I have a common denominator. I don't need to create one. It'd be 9/3. And I can simplify that. I could just say 27x to the 3rd. And that would be my final answer for this. There's nothing else I could simplify. If I were dividing, same concept, 9x to the 4/3 over 3x to the 5/3. Looking at this, look at our constants first. 9 divided by 3, I would have 3 in the numerator. X to the 4/3 divided by x to the 5/3, two things of the same base, subtract those two exponents. 4/3 minus 5/3. Already have a common denominator, I don't need to change that. So what I could say is, that's going to equal x to the negative 1/3. Now, this is where people get confused. The only thing with a negative exponent is this term. So that's the only thing that needs to be flipped over the fraction bar. The 3 would stay put in the numerator, and I would have x to the 1/3. Now, if you want to get super fancy, and you really want to break this thing down, you could write that as the cube root of x, because x to the 1/3 would be written as the cube root of x. Now, if you need to re-watch this, that's fine. You could pause, re-look over some of your notes, but the next activity is just to work on a worksheet practicing these skills, either adding functions together, subtracting functions, multiplying them, or dividing them. So give them a shot.